Okay, so let's go ahead and get this started. We're just going into some very basic intro to computer programming, and just giving you a quick start. This is with JavaScript, and we're going to be trying to follow the ES6 standards. So we're going to start a new project from scratch, and the very first thing we do is we go to GitHub, and we just click on the new. I'm logged into my GitHub account. I click new. And we're going to create a new repository. We're going to call it calc app because it's our application is going to be a calculator. Put it on the repository name field up above. Calc app. And then we just say in the description a simple CLI calculator application. Okay, and we can make it public. Doesn't matter. We don't need to add a README right now. We'll add it later. Don't worry about that. Don't need to add a get ignore. We'll add it later. Add a license. Sure, we can add an MIT license, and then we just click create repository. Like everything else, we're going to just self-manage, and we'll learn how to do that. And so there we've created the repository now. Now we need to clone that repository locally, and I have created a folder under my C drive called proj for my projects. You can decide where you want to put stuff on your local. I'm running Windows, so I just have the DOS command prompt open. But you click on this code drop down, and then there's this little clipboard icon, which will copy the URL for the project that you just created. Now from there, we can actually go into where it is that you want to put your project space, and you don't want to create a folder for your project. It will create it automatically when you clone it. If you have Git installed, GIT, the app, the command line tool installed, then you just type git space clone space and paste. Okay, and then it'll clone that repo, and it should have made a folder now. So I do dir, and there's my calc app right there. So now I can do cd calc app and get status, and there it is. Now we're going to be using this code to do our coding, and I'll just give a quick note. There are some recordings, some tutorials that I have recorded already, where I mentioned that I use Atom, and that was recorded before Atom was sort of de-scoped. So VS Code is the tool, but in subsequent videos you're going to see me using Atom. But don't worry, this recording is being made later, and VS Code is the tool that we're going to be using. Some of the code is in some of these videos that I mentioned I'm not following as best practices. In some of the cases I'm telling you certain practices to follow, but we're actually going to be trying to do it a little bit better in this one. And then we'll also correct in much later training videos. So now we need to open that folder. So we click open, and I'm going to go to where that project folder is, calc app, and I click select folder, and it opens that project. Now we got our license there, and the project is basically completely empty, and we're here ready to start our calc app. Now the very first thing that we do is come in here, and inside our calc app we need to do npm init, and that's going to initialize our project because we don't have a project yet. I mean, we got a project, but we don't have anything in it. So we need to initialize that project, npm init, and it's going to run this npm script, which allows me to create my project in this folder. So it picked up the package name automatically, which is calc app. So I'm going to just press, and I think I want to change that to calc. Well, I guess we can't do any uppercase, but calc app. So just press enter. And for version, I always do 0.0.1. So we're going to create that. And description, I think I could copy paste that from the GitHub page in the about on the GitHub. So I'll just copy paste that. And I can paste it right here. Entry point, we'll just leave it as index.js for now. Test commands, we're not going to have any test commands right now, so just press enter. Git repository, that was picked up automatically. Again, press enter. Keywords, we'll just say CLI, comma, application, NodeJS, training, tutorial, and calculator. And that should be enough. And author, you want to put your full name. So Seth Hollingshead for my full name. Take credit for the work that you're doing. And MIT license, that was the license we chose, so I'll put that in there. And then it generated this package.json for us. So I'm going to click yes, type yes, and press OK. And now we have our package.json in here. Okay, so that's the beginning of our project. Now that we have that, there's a few other things that we're going to need, but we can sort of figure this out as we go.
I'm sorry, I don't believe I initialized my test script correctly, but I can do that in the JSON.
Actually, yeah, there is no test command. There's no test script, so you're 100% fine. So yeah, I just pressed enter and just went through, which is what you did, and that's fine. Okay. So yeah, once you get it generated, you can go back through and edit everything here. Exactly right. You got it.
Okay.
Perfect. Right on. So yeah, if you wanted to add the keywords or make sure you got your name in there, well, it looks like you did. So yeah, all of those things should be fine. Okay. And yeah, there's some, we're going to be keeping this like super basic. There's not a lot here. So a couple of things we're going to need in addition to this package.json. I think you can go to your VS Code now. It looks like everything is good to go. Yeah, there you go. So you got it. We're going to go ahead and create some other files that we need to support this. And one of them is .babelrc. And this may or may not actually be needed, but I think it's a good idea to have it, and we'll put it in here anyways. And then we just put this curly brace, presents, colon, square bracket, at Babel /preset -env, close square bracket and close curly bracket. I'll save that. Then I'm going to add another one for .getignore. And there's a few things we want to add there. We're going to add star node modules /star. And this is just so we want to make sure that all our dependencies don't get picked up and added to our GitHub repository, because you can have a dependency tree that can really explode, and if you did include that could really increase the size of your repository, and you don't want to waste space on your GitHub repo. So node modules /star, and I think those are all the things we're going to need for this project. There are more that we would add if we were doing a larger project, like bin, if we had a binary folder for like a delivery release process, a .env for an environment file. We'd probably want to exclude .log files, .html files in case we're generating documentation. You know, there'd be all this extra stuff here that you'd want to exclude. So yeah, that's and yeah, so those are the big things we're going to need. And then we're going to create a new folder for our source code. So src, and inside source, we're going to create a new file called index.js. Yeah, I like to call them like main.js, but index is usually used for like websites. I'll stick with the index for now, but there is one thing we need to change in our package.json, which is this. Can't just be index. We need to do ./src for the source folder, and then / again. So make sure we save that. And then I think that's the big piece. Also, we would normally want to add like a modules here, or module type equals module, but I don't think we need to do that right now. Also, we probably want to have a start script in here at some point, so I think we can just do this. Start :node, and then we're just going to say /src index.js. And we want to make sure we add a comma at the end of that, otherwise we're going to have an error in our package.json. And I've had problems with this before where you mix that comma. So we want to make sure we have that. Okay.
What values does start hold? Attribute rather, is it? Uh,
Just node./src index.js. You got to have a space after the node. Otherwise it gets messed up. We're basically using node to execute this file. And we'll see that when we run start. So this is like our start script that starts our code, and we just execute that start script to run our application.
okay.
You need a // and then src in front of the yeah, just get rid of that. There you go. Yeah, that's right. Okay, and yeah, you got the comma there, so that's good. And next, we're ready to go into writing our actual code base. Now, the very first thing, anytime you create a file, is we always add headers, and headers are going to be the bane of your existence, my existence, and everybody's existence. But you really have to do it. It's good practice. And headers on functions, headers on any functions on any files. When you run JS docs to auto-generate documentation based on your code base, it'll scan through these headers and it'll use the information from the headers to generate that documentation. So it's an incredibly powerful tool. Also, developers will read, if you ever need to write some source code and other developers have to modify, support, edit, debug, maintain your code, if there's headers there, they can much more easily understand what it is that you've done, when you did it, that it was you that did it and not somebody else, so they can know who to reach out to. If they're having issues, they can contact you if they're struggling with something. So overall, and it shows a history of the things that you're doing. The best way to create a header is to just go / and press enter, and it sort of creates a little bit of a header block for you. If you're doing it over a function, then it will auto-generate a little bit more information in this header like template. So you want to sort of consider that. But we always go with a header. We say @file, and we list the file name, so index.js. And then we go @module, which is this is the application. Or we could just, in this case, say index, which is the name of the file. That's probably the best. And then @description, a small command line calculator application.
Is that a separate header prompt or?
No, you just do. Yeah, you have to press return after you do /**, and then it'll like complete the template for you. No.
Okay.
You already put stuff in there, so you have to get rid of that. Go all the way back to an empty file.
Okay.
All the way back, and then /*, and then press enter. Yep, there you go. Now you can do @file, index.js, @description, and just follow along with what I'm doing here. And then we go @requires. Well, actually, we're not going to do yeah, we do need to do requires, but we're going to come back and edit this because there's some dependencies we're going to add at some point in the future. Now, I'm going to type this out, but later on, you'll be able to copy paste certain blocks of this, and it'll go much faster. So @link https://www.npmjs.com/package/path, and then the vertical pipe and path. Okay, and so that adds an external reference that tells your code base or JS docs when it parses this, or anybody else that reads it, that we are using a third-party dependency called path, and it can be found at this URL. So that it helps with the documentation. And then we do @author, and then my name. Sign your code. Again, take ownership of your code and try to take pride in the work that you're doing. This is part of craftsmanship, and there's agile practices around taking pride in the work that you do and trying to craft the best code possible as part of improving our craft as software engineers. Then we put the date. Today's date is 2023. I always put the year first. It's kind of a European standard, but I like that. And 0609. Okay. Also, we need to add copyright information. So I'm going to copy paste this because it has the copyright symbol in the string. And I'll change the date for 2023. That way you get this copyright symbol in there. And then put your name by your name, all rights reserved. So even if you make your source code like 100% open source, the copyright still resides with you. Like you still own the code. And you can claim ownership over it because your name is on it. And you've got a date as to when it was written. So make sure you do this for code that you write, unless you're working for a company and they require you to put their company copyright information on there. I mean, they're going to be paying your salary, so of course the code owns, they own the code. Unless they tell you you can retain copyright ownership, then by all means retain copyright ownership if at all possible. All right, so we move on down and we do a let path equals require path. And again, this comes to some of my other videos that are in this training series that come after this, but they have been recorded previously. I was using var, but the correct way to do that is to use let. And the difference is...
I have a question about the on line 5 where it says requires, and then you have it wrapped in a curly bracket at link. That link is to the npm package. I can't really read that.
Yes,
npm.
yes, it's basically
Yes.
telling it that it's an external link.
Okay. Okay.
Yep.
Any particular reason why it's wrapped in an object?
That's the way that JS docs will parse this into, so when it parses through this, it'll identify that this is, in fact, an actual link, as opposed to like a string or a description or a variable name or something else. That way, when it generates the HTML documentation, it'll put an inline link in the actual documentation file that links to that HTML path, or links to that, a URL path.
Okay.
Okay, and yeah, so yeah, I'm using the let here, and I had previously described to use var. The difference between let and var is let scopes this variable to be where it's defined. In this case, it's global to the file. If I was to do var, it would also be global. Var is just not as good of a practice, but if I'm always doing it inside of like a function or inside a for loop or whatever block of code inside something, then it would be scoped to that block of code. So maybe it doesn't matter as much here, but it's a good practice to just always use let. And the only alternative is if something is never going to change, then you just use const. Like if you're going to assign it once and you never change it, that's where you use const.
They're phasing var out, right? Is there any use case where var just seems appropriate?
Yeah, there might be, but I mean, it's just overall just not best practice. It's kind of like using goto statements. I'm not sure if you've heard about that, but that's like a big no-no. Like that'll get you in trouble real fast. Yeah, and especially if you're working for companies, they'll frown on you for that, and you might get in actual trouble.
Is that sort of like class statements as well?
That's a little bit different. Class statements have their own. I mean, you can get into object-oriented programming versus functional or compositional programming, and we can talk about that a little bit later. Yeah, compositional programming. I mean, there's always the composition over inheritance, which is absolutely true, and I'm a big advocate for compositional programming. And we can talk about the this operator in JavaScript, but we're opening up a can of worms and getting into more advanced stuff. So we'll talk about that and have that discussion a little bit later. But I'm going to continue here. We go to global.app root equals path.resolve. And then it's process.cwd. And we're just going to put that in there so we can get our app root path. And we're going to use, maybe we're not going to use all of that right now here, but this is also what we're going to, when we actually go to build a framework, we're going to be doing a lot of this. So it's really just kind of about getting into practice here. I'm going to say let root path equal, and we'll assign that to an empty string for right now. And then there's let base file name equals path.base name module.file name path.ext extension name, and module.filename. And then we say let namespace prefix equals, and I'm going to use a backtick here, and we'll talk about that in a second. Application dot $ curly brace base file name, which is the one we just declared on the line above, and I want to make sure I have a dot there at the end and then a semicolon. Okay, so what this backtick does is it lets us hard code a string which has this application dot, but it also lets us do this $ curly brace and then have a variable that's declared in line with our string, right? So now this will get resolved, and the string will, this $ curly brace will disappear, and our variable will take its place. The contents of the variable will take its place, so that it resolves this string, the contents of that string, and puts it in this string in line. So you don't have to, you can do it with a variable that way, which is kind of neat. Okay, so next we're going to set up our first function, and our functions are a way of encapsulating code into little blocks that are, useful for a very specific purpose. And we want to make sure that we're stressing that that functions are kind of like single use and single purpose or single intent. So you don't want to have a function that does, 20 things or even 5 things or even 3 things. You really want a function to really only do one thing. And that way it does that one thing very well. Now we're going to break that a little bit here as we're going through this training, but the only reason why I'm going to break it is so that I can show you then a better way of doing it. And that's kind of my training process. So we're going to go through everything the hard way, and then we're going to come back and go through it, with a cleaner approach. So I'll declare the function first, and we'll just say function application, open close parenthesis, and open curly brace, and I'll press enter so the curly brace goes down a line. Now I come back above the function, press enter once, so I've got an extra line, and I'll do / again, and then again I'm going to press enter so it comes down and it makes that block. So we got to write our headers for our functions, and it's best if you write it right away. After you declare your function and start it, go write that header and just get it out of the way. That's also an important practice to start to build up. So then we go at function, and we put the name here, application. And we can't just copy paste the file header because there are differences. And we're going to see that here in a minute. And plus, you're most likely to make mistakes as you do this. And you don't want to have the copyright in every single header for every single function. That's just crazy. At function, and we do at description. Okay, and I'm going to say this is the main program loop, the init for the entire application. Period. We want to make sure we're trying to follow correct grammar, proper sentence structure, proper punctuation, and all the expectations you would expect from normal English. So try to follow as much as you possibly can. Also, you don't want these lines to go crazy long either, and try to keep them a little bit shorter. And I know it's difficult if your screen is like a super wide screen, but other engineers might not have a screen as wide as yours, so we want to try to keep these a little bit shorter. It's better to wrap the lines around. The only problem is if you do this for a bunch of functions, then you might end up having to scroll a lot, and that's always not the best. But we do have these collapsing things, so you can collapse your code and make it not quite as much to scroll through. And then we do at return, at returns, and void, because we're not returning anything. At author, again, sign your code, put your name on here, take ownership. We're going to be doing this a lot. You'll see it all over. And a date. Put your date on here again, 2023-06-09. Okay. Now we start into the application. Now the application function is a little bit different from our normal functions just because of the way that we're starting everything up. Normally when we're building a function from scratch, we're always going to follow what's known as like a boilerplate, which is kind of a template for functions. So we're going to discover what that boilerplate looks like in a little bit, but we're going to see it sort of a skeleton of it here. Again, it's a little bit different for when you do this with an application. So I'm going to say let function name equal application.name. So I'm capturing the name of the function. Let argument driven interface equal false. This is something that we would use more when we're building an actual application framework. That's not like a little, this is basically just a toy application that we're building mainly for the purposes of training and, you know, as this tutorial goes on. So this is not quite so serious right now, but again, we're trying to get in good practice here. Let command input, and I'm not going to assign it to anything, and I'll say let command result, again, not assigning it to anything. And I could do this. I could just go and declare both of them in the same line, okay, because you can do that with a comma. And then there are a couple here that I do need to assign. So I'm going to say let input data 1 equals 0, and let input data 2 equals 0. Okay, so I can tell you right now the parts that would be normally part of the boilerplate template for a function would definitely be this function name. And now the rest of that boilerplate code is going to look kind of like this. Console.log backtick, and I'm saying begin, all caps, space, $, curly brace, and namespace prefix, because we defined that up here. Okay. Did I get that spelled right? Namespace prefix, I think so. And then over, and then $, curly brace, another one. And we say function name. And then I come over, press spacebar, and say function again. So what this is going to say is begin index dot application function. So we're actually declaring that we are beginning this function. And I mean, right now I've hard coded this with console log. When we get to the point where we're building, and what this lets us do, let me take a step back. What this lets us do is when we're running our application, it lets us debug our application. Now I've hard coded this with a hard coded console log. In the future, what we're going to do is we're going to implement our own console logger, which is actually going to be bound to a configuration management system that's going to allow us to enable or disable logs, especially debug logs. So you just flip a flag and then you're debugging and you're getting all your debug logs. Normally when you're building your application, most software engineers will leave this kind of stuff off. And then if they encounter a bug, then they have to go and manually instrument their code with all these hard-coded console logs just so that they can get access to determine what it is that they're, you know, the bug they're trying to solve. What we're doing is basically pre-instrumenting our code, and then we'll allow a configuration system to enable or disable that instrumentation. So it's a little bit different way of approaching it, but right now we're just hard coding it because we don't have any of the infrastructure in place to be able to do that. And we're not going to implement any of that infrastructure in this project because this is not a framework tutorial. We're just getting started. So I've got the other training videos that explain how to do all of that stuff. All right, so next one is console.log. I can just do a regular single quote. Begin main program loop. And we have a semicolon at the end there. And there's another one here, which we could technically just comment out or leave out, but I mean, I'll put it in and then we can comment it out or whatever. You could leave it in even if you wanted to. I'll explain it here. Console.log, single quote, begin command parser. Now, the reason why I say we could leave that off is because we don't actually have a command parser. We could go implement one, but again, this is something normally you would do on a framework or a larger application enterprise system. But I always leave it in there. I just do because it's my practice. And then we say if argument driven interface equals false. and we do this curly brace, and I'll explain right now what this triple equal sign is. If you've done any programming at all, a lot of times you say, well, isn't it normally two equal signs, like in a C# or a .NET or VB.NET or something like that? And yes, you're right. In JavaScript, it's a little bit different. Double equals is checking for type, like is it of the same type? Is it a Boolean or whatever? But if you're doing three equals, it's checking for literal equality. Like, does this value equal that value? So it's important to know the differences there. And generally speaking, triple equals is the go-to in JavaScript. So just to be a heads up.
In a strict equivalence, does it match the exact character to character also? Like,
yes. Yeah, it's
and value and every
the content, the entire contents is checked because it has to be an exact match. If you want to write an inexact match, like a close match, then you almost have to kind of go implement that yourself. Or otherwise, there might be third-party tools that have stuff like that you could do. I've got some of that in my code base in the framework side, but yeah, that's getting a little bit more advanced from the subject matter here.
Okay.
All right, and then we'll go while program running. So it's a while loop. It's technically an infinite while loop. And sometimes if you're running a linter, it'll complain about this, that it's an infinite while loop and you have to be careful. But kind of an infinite while loop, I mean, we're going to very carefully control that and provide out of this while loop, and we'll talk about that. That way you don't get into a condition where the application cannot exit or locks, almost like a virus, kind of a thing. We're preventing that from happening. So while a linter might complain, you could always override the linter for this particular line of code. We're not going to get too much into that, but you get the idea. And what we call this while loop is called a program loop. And at this level of an application, a program loop is kind of necessary for the program to operate, because otherwise it'll execute once and then it's done. If that is the intent of your application, then that's great for you that you could do that. But in this case, we're going to try and build an application that's more interactive. So basically the application will execute something or ask the user, what do you want to execute? And then you provide it some input and it will go execute it. And then when it's done executing, it'll ask for more input. Say, what else do you want me to do? So this is what we're doing, is this kind of loop of execute, request, input, execute, request, input, just like as if you were working with any DOS program or a bash shell script or anything like that. Those are interactive command loops. They have a program loop just like what we're doing right here. So this is how you do that if you ever wanted to build your own system. And that's exactly one of the things we're learning, is how to do systems like this.
Now, you mentioned a linter can create problems. I actually put in a linter in my program yesterday. I was getting into that. That could give us problems with this kind of function.
Well, what it's going to do is it's going to say this is a problem. And it's looking at this and saying, as if I had done that. Now, if I was doing while true, see right here, correct this loop's end condition not to be invariant. So that's a sonar lint right there. That's it. But you can change the linter rules so that you have to be careful with this.
So it's not, okay.
Yeah, it's basically saying
that's not a problem, but it's saying it's a problem.
Yeah, it's saying that this would be a problem. Now, and it could do the same thing, and see there it disappeared. But I've seen it where it will complain on this even if it's just like that. And in this case, we know what we're doing, and we basically need to tell it, don't worry about it. I got this kind of thing. All right, so then we go to command input equals prompt.prompt. And you're running a Windows box, right?
Yeah.
Okay. If you're running Mac, then that would be a little bit different, because this, or Linux, this would be a little bit different, because the code that we're going to put in this prompt, we're going to implement our own prompt. And if you're running on Mac or Linux, then the prompt that we're going to implement would not work for you. So there are other ways of implementing a prompt, but you can use a third-party dependency. It's like prompt-sync is an npm module that will do the same thing.
Okay.
Or if you actually change your code to do asynchronous code, then there's a much simpler way of doing this that's really easy. But we're going to do it ourselves, and that way you could learn a little bit about how that works.
Okay.
All right, so then I'm going to put in a string here to prompt the user of the application for the input. So I'll say enter a math operation, right? It's a calculator app. What do you want me to do? What kind of math do you want me to do? And now we're going to have to process that input. So the user is going to, now I haven't written prompt. I wrote it here in the line of code, but I haven't implemented the actual prompt. And we're going to do that, and you'll see how it works. Okay, but first we need to come here and we say if command input dot to before we do that, dot command input dot trim equals exit, we'll say exit or command input dot trim equals single quotes. That was all uppercase. Now we can do uppercase E exit or command input dot trim equals all lowercase exit or command input dot trim equals single quote all uppercase quit or command input dot trim equals uppercase Q lowercase it, oops, double pipe, command input dot trim equals all lowercase quit or, and you kind of see what we're doing here, command input dot trim equals single quote uppercase Q or command input dot trim equals lowercase q or command input dot trim equals uppercase X to exit or command input dot trim equals lowercase x. Yeah, you kind of see what we're doing there. So you see what I've done, and I'll have a curly brace at the end. It's a lot. And again, the reason why we did all this was to show you, you know, there maybe the wrong way of doing it, because that's what this is. This is the wrong way.
Okay, that's the wrong way now. Okay.
Yeah.
So that, are we setting up? Well, now you're telling me it's the wrong way, so I'm thinking maybe I should change my idea. But I mean, are we setting up inputs, right? We want those inputs to correlate to those outputs, I guess.
Well, yeah, we're basically processing whatever the user entered, and we want to catch the case that the user entered any of these combinations.
Okay.
And we could go ahead and put the implementation here. Let's do this. Let's go ahead and put the implementation inside. I'll do a console.
It's like we're writing our own types.
.log end command parser. Again, we don't have a command parser, but I'm just putting it in here anyways. Command parser. Okay. And then we say program running equals false. Not triple equals, single equals. So it's assignment. We're assigning this false value to this variable. Program running. And then we say console.log end main program loop. Okay, so that program loop is now going to be exiting. Now that we have set this program running to false, this this while loop is not going to be running once we finish this. So then we can say console.log exiting goodbye, have a nice day and stay safe. Okay, good. All right, that's done. Okay, So now make sure we save that. So you got the little dot up here, and when you click save, it goes away. All right, so let's take a look at a better way of doing this. And this is getting around like starting to think like a software engineer. So you've got exit, exit, exit. Well, what if, and then quit, quit, quit. The only difference between these, they are different. Like if this string comparison, would show different if I just did this differently. If I entered quit and I didn't all uppercase and I didn't have this in here, it wouldn't quit, right? Or if I removed, these two, or maybe let's say if I removed this one, I would have to type it in one of these. If I typed quit in lowercase, it wouldn't quit. It would just keep running. Ask for more input. What else do you want me to do? And that's not what we want. We want it to quit. Well, the only difference between these is, the case. This one's all uppercase. This one only the first letter is uppercase, and this one they're all lowercase. So there's got to be a way that I can force this input to be all uppercase, but only for the purposes of this comparison. And there is a way, right? And the way is to put something right in here. It's a modification of the command input. And so what we do is we say .to uppercase, open close parenthesis. So now I'm converting this command input to an uppercase, I'm trimming it, and then I'm comparing it if it is equal to exit. However, this .to uppercase, it doesn't change the actual command input. Like the command input stays the same. It's just resolving it for the purposes of this comparison when this line of code executes. And then that's the comparison that's made, right? If I did enter lowercase exit, it would uppercase it, and then it would compare it against this, and if it was a match, then it would exit. And that's exactly what we want. So then we can remove these two extra lines. Okay. And if I do the same thing here, I can copy paste that and just go there, .to uppercase, open close parenthesis. Now I'm checking with quit. Again, I can remove these two lines of code. Gone. I'm simplifying my code. I can do it again here. Yeah, this is called refactoring. I'm readjusting or rearranging my code to be more efficient, right? To uppercase, trim, Q. So I don't have to do this lowercase q because I'm doing it in line with that one. I do the same thing with X. Dot. There you go. To uppercase. Check that. And I want to make sure I don't remove my parentheses. So I got to do that and then come around and get rid of that extra or at the end. So yeah.
Now, you're scoping, right? You're scoping your method call, or what? How are you able to exclude all those extra characters?
Because it's doing this to uppercase and it's doing it in line, right? So it is comparing the condition that I enter all lowercase quit, or I enter all just the lowercase q.
Oh.
Right? Because it is converting it to uppercase before it makes that comparison. Does that make sense?
Almost, yeah.
Basically, this might contain lowercase q. It converts it to uppercase, and then it trims it, just in case I entered a space or something else afterwards.
Oh, okay.
And then now it's comparing if that q that I entered equals the uppercase q, right? And I mean, if you type T, it's not gonna catch it, right? But if you enter Q, even a lowercase q, it will now catch that Q equals Q, and it will exit.
Okay, and so to speak, I guess instead of initializing or defining each thing literally, you kind of the operation happens within the
within the line of code.
Within the line of code, yeah.
Yeah, it's just all happening right here.
Through the method call, because those are method calls that are within JavaScript.
Yeah, these are chaining. They're not necessarily in JavaScript. Well, maybe they are in Java. I mean, it's basically a modifier on the string And so, I mean, you could research this, and you're going to find it'll probably be in W3 schools. You might have even glanced over it while you were reading, and it's so much. I recognize that you're reading a lot, right? There's tons of content there, and you probably don't remember all of it, but that's okay. That's why we get in here and do this. And you're not supposed to remember it. You're just supposed to bathe yourself in it so that you start to, marinate in the concepts and ideas. And then when we actually go into this training, you're not completely clueless, right? We can do a little bit more. So yeah, that's kind of how that goes. And I got some extra spaces there. Let's clean that up. And then we move on. Okay, so right down here after this, I want to do at the very end. This is again coming back to the boilerplate code for a function. Console.log. Again, backtick end $ curly brace. Namespace prefix, and then over $ curly brace function name, and then we go over again and we type function. Now what I could have done is I could have just copy pasted this and then just change that to end, right? Because that's the only difference between these two lines of code. And this will help us with debugging if we ever need to. Again, they're hard-coded, so it's not the best right now, but it does sort of get us in that practice of pre-instrumenting our code. And I'll go ahead and uncomment that command parser. By the way, to comment and uncomment, you can just press, go on the line and press, or even select multiple lines. Come on, out of the way. You can select multiple lines and press Control /, which is right next to the right shift key, okay? And it'll auto-comment all those lines out. And to uncomment them, you do the same. Control /, and it will uncomment them. So that's a fast, easy way of commenting and uncommenting, sections of your code or single lines of your code. So it's important to remember, these little things. I'm just reading this. Add the let const or var keyword to this declaration program running to make it explicit. Did we not? No, did we not declare that? Oh, you know what? Haha. Okay. Yeah, there's a little bit more we have to do. We haven't declared program running. That's why I'm getting this little linter error. But we're going to get into that here in a second, because that's the next thing we do. We go down here after the application function. We come down here and we say let program running equal false. And one other thing we would do here is if we were building a more advanced system, we would have a bootstrapper that would bootstrap in a framework or applications, tech stack that we have built. I'll just say bootstrap application, and we would do it right there. And then after we call the bootstrap, which in this case we don't have a bootstrap, and we're not going to because this application is very, very simple, but that's where you would do it. Then you would say program running equals true, because now the application is running, we're done with the bootstrap, and then we just call the application. Okay, save that, and yeah, we should be good now. So this should be all you need. Also, I'm doing a require here. I think the better way is probably to use an import. But if you do an import, then you have to make your program into a module, and it just gets really complicated after that. That's the more modern approach, I would think, and it is. But let's see if this program actually runs. Like, can we do it now? So CLS clears the screen, and I'll just say npm start, which is how we run that start script that we defined at the very beginning, package.json, start. Now, if we wanted to run some other scripts in here, normally we would have to do npm run, like npm run test. But npm has built in some stuff that allows you to define the start and the test npm scripts where you don't have to do the run. So we can just do npm start or npm test. But if you define other ones like npm build or npm release or npm deploy or npm docs or npm version, right? All of those things are things that you can, little scripts that you can write to build your own CI/CD DevOps platforms, your own documentation tools that are automated and allows you to do all those more advanced stuff. Then you need to do a run version or npm
I
run.
was told in a boot camp I attended that you could actually become a JSON developer, right?
Yes, you
Or a
can.
JSON developer.
You can do like a lot of stuff off of JSON, and when you get into it, JSON forms the basis of the execution environment. So it's the data. There's a data environment that we're running as part of our executions engine, and that absolutely forms a big part of it. Not only that, but you can take your functions in your code base and you can load them into JSON as functional callable objects, right? And so then your code becomes, the code that you write becomes JSON objects which you can execute, and so that kind of gets to what you're talking about there.
Like backend data stuff. Okay.
Yeah, but it's all existing inside runtime JSON objects, and that's actually what I built in my platform, and we might get to learn about that in future lessons, especially when you go build the business rules on the program training number 2. I think it's maybe 3 or some further down the line. Anyways, okay, so we go npm start, press enter, and your application should run, and mine gives an error. So namespace prefix is not defined. So I've created a problem for myself somewhere. Let namespace prefix is not defined. So I'm missing something here. What am I missing? What was the line on the error? What was the error? Namespace prefix is not defined. Line number 30. It says line number 30. Okay, so yeah, I found out the problem. It's very simple. It's just this uppercase P right there. It needs to be uppercase. Super simple. If you miss that, it's not going to work. Okay, so we can come back here and try to run it again. Let me move this off so you can see it. CLS, npm start. Oh, now we got another bug. Okay, prompt is not defined. Oh, yes, of course, because we don't have a prompt yet. Okay, so we need to do a prompt. We need to actually go and build our prompt so that this will work. Let me try and...
That's crazy. So you wrote logic that actually is somehow talking back to you.
Well, it's not really talking back. It just errored out. And
it was errored out. Well, yeah, I want to see it execute. I have
we're going to get there.
Here.
Let me comment this one out. And I want to actually execute it. Now it's gonna go into an infinite loop, and I'm gonna have to cause it to crash, which is okay. We can just watch it run though. Npm start. So something else happened. Let's see, what else am I missing? Oh yeah, look, see here. Begin application.index.application function. Begin main program loop. Begin command parser. And then there's this to uppercase. Cannot read properties of undefined, reading to uppercase. So because we commented that out, there is no command input. And so actually what we should do is, if we're going to do this properly, we need to wrap this in another if to protect ourselves from some sort of invalid input. Because that's what this is. That's what this is. I fed it invalid input, or I didn't feed it input at all, which is the problem. Right? So if I say if command input, in other words, there has to be something there, or you could say command input equals true, but that gets a little sketchy because strings should evaluate as true and empty strings are evaluated differently. Anyways, yeah, I would go like this. If command input means there's got to be something there, it's not undefined. Or you could say not, which is the exclamation mark, double equals undefined would be another way of doing this. If it's not undefined, then let's copy all of this, Control X, and put it right up here. Okay, and it carried over some weird formatting here, so let me tab that over. And this needs to now be tabbed over because it didn't get the formatting of that. There we go. Okay, tab order is important. We want to make sure we're getting the right format here so it sort of
Right.
makes sense from a readability perspective. And this is
I'm
again
trying to
about
see
keeping
where
code.
in the case check. I'm trying to see where you've actually closed the your argument statement. If so.
Yeah, I closed it right there at the end of the.
Okay. No, it's see, I've closed it here too, but for whatever reason.
See, yeah, you've closed it down at the end of the contents that are supposed to be in that. Right, you just moved all of this inside of there, so it needs to be up here after the end of the two uppercase.
Two uppercase. Okay.
Like you've got all of this code like blocked in between these two lines right here.
I don't see it.
All right, let's try this again. Let's see if we can
While
run this.
If and then yeah, and then the application. All right,
CLS,
and then I can run it.
npm start. There it is. So now it's working, and it's not asking me for input because it's stuck in this infinite loop, and I commented out my parser. So it's infinite looping, and that's a problem. I mean, now I gotta Control C will get you out, and you can press yes, and it'll terminate the job. And you got your prompt error. Yep, prompt. So now comment out your prompt line. Go to line 30, your line 35, and just press Control / anywhere on the line. Yep, save it. And then run it again. There it is. So now, yep, you're running into an infinite loop, just like I was. So you can press Control C to terminate, and yes to terminate, and there it is. So now you're terminated. Okay, so you are terminated. Get to the chopper. All right. So now we need to go write our prompt, right? Let me go ahead and we'll just have to do that on the next session.